To show you how to bias a transistor, I have selected my components. So in this case, I'm going to show you how to bias NPN transistor and PNP transistor. So in this case, I selected my component. I have 220 ohm to limit the current through my LED. I have 10 kilo ohm for biasing my transistors. So I have 9-volt battery. So to draw your attention to how to bias a transistor, the selection of the base resistor and the current limiting resistor depends on your input voltage or the voltage you are going to use. So I'm using 9 volt, so 10 kilo ohm should be enough to bias the base of the transistor. All I need at the base of that either NPN or PNP transistor is something above 0.7 volt. So let's get on. So let me start by showing you how to bias an NPN transistor. So earlier on we established that the base is in the middle, then this is our collector. So I will place it this way on the breadboard. So in the case of NPN transistor, you connect, it is recommended that if you are going to bias it as a switch, you connect the emitter to the negative side of your power supply or to ground. So let's connect our emitter. This is our emitter. So the emitter is connected to, we take this as our negative side. This is our biasing resistor. Here it is here, or you can put it directly on the row where the base is connected. So it's okay to minimize the use of jumpers. This is our LED. Let's see how. So we'll connect our LED. So we connect the LEDs. We will connect the positive side of the LEDs, which is this point, to our positive side of our power supply. This is a current limiting resistor, so depending on how you want to put it. So let's, for clarity, let me put it here and use a jumper wire to connect it directly to the collector. This is the collector. So this is the collector. Our emitter is already connected, so all we need is our power supply. So I'm using 9 volt. This is my VCC, and this is my ground. So in the case of NPN transistor, all we need is a positive supply to the base. So this is a positive supply. So let's connect the positive supply to this resistor. So it's lit. So you can, this is how you bias it. So let's go over the configuration, the connection again. Notice that the emitter is connected. The emitter is connected to the ground or negative side of our power supply. The resistor is connected from the base to the positive side of our supply through a jumper. Then this is our indicator light emitting diode, is connected to the collector through this jumper, through this current limiting resistor. Without this current limiting resistor, it will damage the LED. Then the positive side of the LED is connected to our power supply. So this is how you bias an NPN transistor. So let's go over and I'll show you how to bias a PNP transistor. So let's remove our power supply. Yeah. So for the NPN transistor, we use the 2N222 transistor. So for the PNP, we are going to use BC557. So we established that the base is in the middle. So let me place it on the board. So so in the case of PNP transistor, instead of connecting our emitter to the ground, we'll connect our emitter to the what? VCC. So we will take this side as our VCC. So we are connecting our emitter. Let me remove the power supply. We are connecting our emitter to VCC. Then we are connecting our, let me place our LED. So where it was, this is our LED. So we'll connect the negative side of the LED, the negative side of the LED to the negative or to our negative or ground. Then we use a current limiting resistor as we use in the case of NPN. So this is it, to connect it to our collector. Then we have a biasing resistor. We connect it from the base, and then we use a jumper wire to test. So let's connect our power supply with things being equal. So this is our negative side of our power supply, this is our positive side. So it is advisable that you double check to make sure that there is no mistake or no mistake. So with things being equal, in the case of NPN transistor, we bias the transistor by sending a positive signal to the base, but in this case we are going to do the reverse. Because of this N, it means that the base is going to be biased with the negative side of negative or our ground. So this is negative or our ground. So you can see that we successfully bias a PNP transistor. So that's how we bias PNP transistor, and we did that of NPN transistor. So you can see that these are two different transistors in terms of biasing configuration.